In order to graph a logarithmic function, it's often useful to first graph the exponential function that is its inverse. This should be familiar. Making a table of values for the function y equals 2 to the power of x gives us these 7 key points. All we've got to do to get 7 key points on the graph of log base 2 of x is to swap the x and y's. An inverse function is simply our x values become our y values, and our y values become our x values. Now we've got some nice key points for the log graph. I've plotted the graph of y equals 2 to the x here. You can notice some key features. It's got the y coordinate 0, 1. It's always positive. The domain of this function is all real numbers. I can choose any value for x. The range, however, is y must be greater than 0. We have a positive base, and a positive number raised to any exponent will always result in a positive, and as a result, this graph is always positive. It also ends up with a horizontal asymptote as we move this way. As I raise 2 to larger negative numbers, the result is actually smaller and smaller numbers. Therefore, we get a horizontal asymptote. The graph is tending towards 0, but never actually reaches it. Here I've plotted its inverse. You can see that all the points have swapped. This key point 0, 1 became the point 1, 0. The y-intercept is now this x-intercept. When we take an inverse, the domain becomes the range, and the range becomes a domain. So you can see that my domain of x is an element of all real numbers becomes the range y is an element of all real numbers. And the range for the exponential graph becomes the domain for my logarithmic graph. X is an element of all real numbers, but x is greater than 0. And where this graph had a horizontal asymptote, y equals to 0, the logarithmic graph has a vertical asymptote, x equals to 0. You can see over here that my graph is getting closer and closer to the y-axis, but it will never touch or cross. The transformations on logarithmic functions are the same ones we've already seen applied to other functions. We've got vertical stretches, horizontal translations, and vertical translations, your a value, k, d, and c. Once again, be careful about these two. Your k value is a horizontal stretch by a factor of 1 over k, always take the reciprocal, and your d value is always in the opposite direction you expect, a minus sign is to the right and a plus sign is to the left. This d value tells us something important, however, about logarithmic functions. If you recall, the base logarithmic function has a vertical asymptote at x equals to 0. If my entire graph has been shifted left or right, my vertical asymptote goes with it. So this d value gives you the vertical asymptote of your logarithmic graph. Let's do an example. So for example, this is a logarithm, base 2. I've applied 1, 2, 3, 4, 5 transformations to it. This is a reflection about the x-axis. This is a vertical stretch by a factor of 2. This is a horizontal stretch by a factor of 2. This is a horizontal translation 3 units to the left, and this is a vertical translation 1 unit up. We're going to do this in 3 steps. First off, let's just find the key points on the log base 2 of x graph. Until we get the hang of it, it's often useful to first generate points on the 2 to the x graph, its inverse, and swap the x and y values to get some key points on log base 2 of x. Once we've got a few nice points on the log base 2 of x, the parent graph of this function, we're going to want to map them or transform them to the new key points on this graph. Because we're taking our x values and multiplying them by 2, we're stretching the graph horizontally by 2, take the x coordinate, multiply it by 2, and because we're shifting everything 3 units to the left, subtract 3 from all the x coordinates. Similarly, take your y coordinates, multiply them by -2, that will flip them and stretch them by 2, and then add 1 to move them up by 1. That results in these 5 key points. Taking the x values, doubling, moving 3 over, taking the y values, making them negative, stretching, and 1 up. Don't forget, this number is important. The d value gives you the vertical asymptote of the new graph. This one has a vertical asymptote at x equals -3, since my graph was shifted 3 to the left. Lastly, we're ready to sketch. Once you've got a few good points plus your vertical asymptote, I've plotted a dotted line where my vertical asymptote is. I know that my graph is going to approach that line, but never touch or cross it. There are the nice points I found. Nice smooth curve, and there we have it.